So today I'm going to talk about one of my projects. Actually, I'm going to talk about two projects, one now and one at 11. And this one is sort of more of a, both of them are hobby projects, more or less, but there could be very interesting applications for that. So what I'm going to do now is to make this presentation using the tool I'm going to be talking about. And so you'll see that in a moment. But what I'm running is a command line application that's going to display a sequence of images. And the images, what you see on the screen, are all these slides. So I created a PowerPoint slide, and I saved them with a bunch of images. And I'm going to just display the images in sequence. So that's basically the presentation. So the title of my talk is Using Tornado to Build a Graphical Terminal Interface for Multiplexed Remote Access. So each of these things will be explained as we go along. So what I'm going to do is to begin by explaining what's Tornado. How many of you know about Tornado? OK. So for those of you who know, it may be a bit of a repetition, but there aren't that many people in this room, so feel free to interrupt me when I'm talking. I teach, and I like my students to interrupt me when I'm talking. So most often people wait till the end of the talk for questions, but let's make it more interactive, especially there's not that many people here. So if I say something wrong with Tornado, for example, you can stop me right there. So I work here at Texas A&M, and you can reach me at this email address. I'll upload this talk. I think this is going to be online as a video as well, so you can reach me. Exited that accidentally. A bit more about myself. I'm a professor at Texas A&M. I teach meteorology and basic programming, and I do research on climate modeling using supercomputers. I've worked on open source projects for about 15 years or so. And I haven't used Python for very long, it's about 3+ years. So I'm not a real expert on Python, but I've used the computers for a long time, over 30 years. And I've been using the command line, the terminal, to use the computers for over 30 years. So I've been using computers since the days of punch cards. So I've been using the command line pretty much since it started. And things haven't changed a whole lot. My first terminal was a VT52, actual VT52, not an emulator. So, and the nice things that have happened since then are tab completion, you get more powerful shell commands, but the basic philosophy of the command line hasn't changed since the Unix system was invented. So what I'm going to talk about today is, in some ways, how we can extend this command line to do some really cool things and useful things, hopefully. But before that, I'm going to talk about the tool that I used to do that, and that's Tornado. That's a web server. And it's a tool invented to solve what's called the C10K problem, how to have, let's say, 10,000 users connected simultaneously. And traditional web servers like Apache, the oldest one, can't do that because they have one thread for each client who's connected. So if you have a massively online course, for example, and you have 10,000 students connected simultaneously, Apache wouldn't handle that because it would need 10,000 threads to do that, and that's too many. They have pools of worker threads, they're reused, but it's still too much for traditional servers, which are multi-threaded. So people invented asynchronous servers. Typically, they're single-threaded. You'd think that's a limitation, but actually it makes them much faster because they use a single thread to handle multiple clients, and they don't wait for network I/O. So if the server sends you a packet to display on your browser, it doesn't wait till it gets to you. It just does something else in the meanwhile. And Python supported this initially using the async core module. And then there's Twisted, that's the oldest asynchronous framework. And Tornado is fairly new. It's about 2009. And there's something called G-Event, which I put an asterisk because it's not pure Python. You have to do some kind of patching. But apparently, that's the fastest. Tornado is reasonably fast, and it's similar to Twisted. And the others, which are not Python, which are this Nginx and Node.js, this is sort of the hot thing now in JavaScript. But it uses JavaScript, not Python. But it's also asynchronous. What I'm going to talk about today is Tornado. And I keep forgetting I'm not using PowerPoint. That's why I'm doing this. So that's a brief description of Tornado. It's a web server with simple templates. It's got asynchronous networking, so you can use it for other things other than web servers. It's just like Twisted in that respect. And it's got modules that can do authentication, so you can use Facebook, Twitter, or Google to sign on to the web server. It has this standard support for the Python web interface, and it can also be used in the Google App Engine. So these are just some important features of Tornado. The nice thing about it, and the reason I'm using it, it's pretty small. It's fairly new. It doesn't have that many features. It's not a full framework as such. And if you have any problems with how it's running, you can just go in and look at the code. It's really small, actually, and you can actually change the code as well. So that's probably the strongest aspect of Tornado for, especially if you're playing around with things or developing things quickly. It's actually developed by a company called FriendFeed, which was acquired by Facebook, so I presume Facebook uses Tornado internally for something. It open sourced in 2009, and it's used by a bunch of companies, Quora, big one, Bitly. And so it's not as popular as some of the other ones, but it's really nice to use, especially if you're a single person trying to tweak code. It's a really nice thing to use. So if you haven't used Tornado before, there's a simple example of an application. It only takes an application this size to set up a web server. Let me go over it. You import something called IO loop, that's the event loop, and the web request handler. So you declare a class called main handler that subclasses the request handler. And you have get, so this handles all get requests. And all the server does is echo, it says hello world on, and it has a write method. And this sends hello world back to the user. So the user will see this on the browser. So you just need the simple class to handle a get request. And the main program, you say application, you create an application and say all requests. So this is the pattern matching. It says match all requests and send them to this class main handler. And this says fire up the application, listen on port 8888, and start the event loop. That's all you need to set up a web server. And as I said, this can actually handle about 8,000 simultaneous users because it's a really powerful web server that way. And it's very lightweight and very fast. I said I'd talk about asynchronous servers, and it's not multi-threaded. So what happens is, let's say you're serving a web request and the user wants something. Let's say the user wants a weather forecast. The weather forecast may not be on the computer itself. It may be in a database somewhere else. So you don't want a single thread that is running on to stop while it serves the request. That's the whole point. So what you can do is, when you're serving a request from the user, you can split the get operation into two parts. The first part is still called get. And what you can do is to, let's say the weather forecast is in the web on a server somewhere else, and you want to get that and package it. You fire off an asynchronous client that gets the forecast, and then you say fetch. And you see a decorator on top? What this decorator does, it tells Tornado that this is an asynchronous request. So as soon as this fetch is executed, the single thread returns control to the main event loop, and it starts serving the next request. It doesn't wait for the response of this. What happens here is you provide a callback. So when the weather forecast comes back, the callback function is called, and what this does is it renders the final response. So you could have, let's say, 10,000 people asking for a forecast. What the server would do is fire off 10,000 requests, but it won't be waiting for any of them to return. So as soon as any of them returns, it'll fire the response back to the user. So that's the asynchronous part of Tornado. And that's what makes it feasible to handle a large number of users without using just a single thread. And single-threadedness actually is convenient in Python. If you're aware, Python is essentially single-threaded. I mean, yep.
So you have to explicitly using the decorator?
Yes.
So by default, it's asynchronous like
Yeah.
everything else?
By default, if you don't put the decorator, you can't do this.
Okay.
Yeah. There's another way to do it I'll talk about in a moment. But yeah, you need to do something extra to say it's asynchronous. Because if you're serving a local file, it'll be synchronous. You wouldn't want to wait. You do this for things which would take like a second. If something takes 100 milliseconds, you probably wouldn't do this. So it depends on how long it's going to take. So all you need to do is to put a decorator and split your request handling into two parts. The first part just calls something else, which is going to serve the request. The second part completes the request. The other way you can do it is it's much more advanced in Python. So I'll spend a bit of time on that. So you see, it's similar to that. So this is doing the same job as the previous one. Again, a subclass request handler. And you you say it's asynchronous, but there's another decorator called gen engine. And here you don't have two methods, you just have one method called get, so that's the difference here. And the gen engine uses what's called a generator. Okay. So the first line is the same, it starts an asynchronous HTTP client. The second line uses a yield statement. And some of you may have used a yield statement in Python. Originally, the yield statement would not have something that it takes as input. What this yield statement does is, this is what's called a generator. So initially, Python had iterators, and I think it's 2.5 or so. They extended it to include generators. So now yield takes both an input and also provides an output. So for an iterator, so if you're looping over something, if you use a yield statement, it just yields a value, the next value. But here, the yield statement takes a value, and the value it takes is the fetch operation. So here, you're querying the domain example.com for something that's going to take some time. And the query request is wrapped in this gen.task function. And that's provided to yield. And what happens in Tornado is when this yield is executed, control goes back to the Tornado event loop. Okay? So this callback function sequence is basically folded into this yield statement. So it makes it sort of cleaner. The get operation, actually single operation logically, it just happens that it pauses to get a response. So by using the generator, what you can do is just make it look like a single function. And basically the thread control yields at this point until this fetch function returns a value, and that value is assigned to response. Okay? So you can have like 1,000 of these hanging at a time, and the Tornado event loop handler will handle this. And as soon as any response comes back, it will resume execution. So this can be really powerful. Let's say you're querying 5 different places to construct your response to the user. It should be one method, but you could have 5 different yield statements, and each of them will pause till the next answer is received. Okay. So this is one of the powerful features of Tornado. And this is also getting into other languages and other servers as well. But so if you want to understand more about this, look up the iterators and generators portion in your Python textbook or online reference. And so Tornado uses generators to implement this. This is fairly recent to Tornado. It's been there for about a year or so. And before that, you had to do this to serve asynchronous requests. Yeah.
In my experience in doing a similar thing with Twisted, I found one thing that's worth noting is if you want to see the result of that yield, you have to set your breakpoint on the next line or do something with response.
Oh, if you're doing breakpoints,
yes,
debugging?
Yeah.
Actually, you should come to my talk at 11 because I have a debugger that handles this.
Oh, okay.
Yeah, because it's a real problem. One of the problems with the asynchronous programming is if you try to debug it, you might have 1,000 requests, whatever, 100 requests. And they're all in different stages, and it's totally crazy if you're trying to, you can't step through the program. It's just crazy. You can't do that. Yeah, but that's my talk at 11 because I had the same problem when I was trying to debug this. And I mean, especially if you set a breakpoint, it's going to stop all 1,000 requests. Okay, you can't debug one request at a time. But that is the solved problem. Come to my talk at 11. So, but yeah, the logic, it appears simple, but the internal logic actually is much more complicated in this case. It's hidden from the user. That's all. The other feature I'll be using that's also fairly new is called WebSockets. And it's basically bidirectional HTTP. It's like TCP. So it's like, it's been fully functional for about a year now. Actually, December 2011, the spec was finalized. And what it does is it allows any web server to establish basically a TCP connection with the browser effectively. And it's very powerful because there's no delay in sending a request and getting a response. You don't actually send requests and responses anymore. You can just send packets like you do in TCP. So this is almost like you have an application running on a desktop, except the program is somewhere else. So that's an important feature in the application I'm going to talk about. And the protocol has been around for about a couple of years, and its final version was finalized about 8 months ago. And the question is, how much do browsers support it? Oh, okay, we'll come to that in a moment. I think there's a slide later. So this is how you use it in Tornado. And Tornado supports WebSockets very easily. That's this example here. So to use WebSockets, what you do is you subclass WebSocket handler. And so you just need about 3 methods to use it. So you say open. So as soon as the browser opens a WebSocket connection, this is opened. This open method is called. And then every time the browser sends a message, onMessage is called with the message. It's just a string. And when the browser closes the connection, onClose is called. So this is really simple to use. I mean, I'm amazed at how simple things are in WebSockets. It's an extremely simple protocol. So you can really write something that gets input from the browser and sends a response back. The self.write sends a write message, sends a response back to the browser. So the browser can send you anything, and your server can send anything back to the browser. And it happens without any latency of setting up a request and so on. So this is on the Tornado side. As I said, Tornado, you just get this module, the WebSocket module loaded, and you can start using it. You don't need to do anything extra. On the browser side, in JavaScript, you need these lines. So this is where we open a WebSocket. So if you're coding JavaScript, you say new WebSocket and the URL that you're connecting to. And this can be the same URL as your web page. So that's really nice. You don't need a separate port or anything like that. And you have an onOpen method. So as soon as the browser connects to the server, onOpen is called. And then onMessage. So as soon as you get a message from the server, onOpen is called. And the send method sends a message to the server. And when you send, it goes to onMessage here. So 3 methods here and 2 methods here, and that's all you need to set up. Yep.
Hey, is that Tornado specific, or is that just any Python backend?
Oh, the JavaScript is a standard for anything. This is a WebSocket standard.
But the WebSocket handler, that's Tornado, right?
This is Tornado, but pretty much any web server would implement the same thing. These are the standard methods that the protocol supports. They might have, they could have different names, I guess, but that's the only thing. These are the 3 methods. The protocol basically defines these methods. And all Tornado does is implements it and makes it easy for you to use. So it's, again, out of the box. You can start using WebSocket examples that come when you download Tornado, how to use WebSockets. But this is something that's really powerful, and it's just catching on. And the reason it's just catching on is this is what browser support for WebSockets is. This is Internet Explorer, Firefox, Chrome, and so on. So what you can look at is the bottom few rows. This is, you can see version number is going crazy. It's Firefox and Chrome. They're all going 17 and 23. But it's kind of arms race going on. But the colors don't show up that well here. The light green means it's supported. And basically, Firefox supports it, Chrome supports it, Safari supports it. And very importantly, the mobile Safari, where's that? I can't see. iOS Safari supports it. That's very important because it runs on iPads and iPhones and so on. And the thing that's not fully supporting it yet is Internet Explorer. IE 10 supports it, but I think it's not fully released yet. That's a big bottleneck. But pretty much everything else supports it. And they've been doing it for about a year now. And so you can actually start using WebSockets, assuming IE 10 will become commonly used. There are hacks which can get around this, but they involve Flash and things like that. There are ways to implement it in older browsers. Okay, I'm getting close to the end of, this is the end of the Tornado part of the talk, but I'm actually happy to stop here because I'm going to talk about things other than Tornado. If you have any questions about Tornado, it's a good time to. Any questions? As I said, I'm really happy with it. The really nice thing is you can go in and change the code or look at it, and it's not very long at all. It might even be smaller than your program if you're writing a big program, so it's a pretty small piece of code. I know people have been using Twisted, and there's some controversy. I think when Tornado started, why start Tornado? Why can't you use Twisted? I haven't used Twisted myself, and I figure it's very powerful, but it's also pretty big. So that's. Okay, now we're going to talk a bit about terminal multiplexers. And these are programs that let you operate multiple terminals simultaneously and do things like, if you're at work, you open up your terminal, you can go home and get the same terminal back. Okay, so you don't have to save your work or anything. The oldest one is called Screen. Later one's called Tmux, and there's a variation called Biobu. And what these do is they basically hold the terminal state on the server. And people use it all the time. If you're running a server that you can log in from any computer and still see the terminal output of the server. And these are basically typical command line. They look like your terminal, except they can multiplex. Different terminals can appear on the same screen at the same time. So now I'm going to shift gears and talk about the terminal interface, and we're going to use Tornado and WebSockets to do something really nice with it. A GUI is a graphical user interface. This is a very nice code I saw online. A GUI gives you sentences you can say to express yourself, and a command line gives you words. And when you're a beginner, you want a GUI because you don't know how to make sentences, and you want to do some actions. But you're an expert, it's limiting because you only have a menu of sentences you can work with. You can't construct different sentences with the words that you have. So I use both. I use a Mac, and I like the GUI for certain things and the command line for certain things, and always wondered that why can't you combine the two, get the best of both worlds, and hopefully not the worst of both worlds. There are bad things about the GUI and bad things about the command line as well, so you want to try and avoid it. So this is a project that I'm going to talk about. It's called GraphTerm, stands for Graphical Terminal Interface. The goal is to seamlessly blend the command line interface and the graphical user interface, and avoid the problem that you lose the good features of any one of them. Actually, you will lose some good features of the GUI, but it's going to be fully backwards compatible with Xterm, so you don't lose any good features of the command line. So you can use everything that you do in the command line without losing anything, but add some features that you do on the GUI. And it builds upon some earlier projects. There's one called XML term and called Ajax term. I've been using it myself for the past 7 or so weeks. So I've stopped using Xterm. That's the only way I know that it works properly. If there's a problem, I fix it right away. There's a project page, and there's a GitHub page where you can get the source code, and you can just Google for GraphTerm if you don't remember anything. I picked it so that there are not many other Google hits on it, so you'll be able to get there if you just Google for GraphTerm. So the server part is about 4,500 lines of Python. It uses Tornado and uses WebSockets. This is going to be a terminal application. You want it to be responsive, and you can't use regular HTTP to do that. You have to use WebSockets. It won't run on IE9, for example. So it only works on browsers which have WebSockets. The client is basically JavaScript and runs on the browser. And so what it does is it adds a new mode to Xterm. If you're familiar, if you use your terminal, you know that if you fire up VI and Xterm, whatever you had before goes away and a new set of text appears. That's what's called a screen buffer. When you finish editing VI or Emacs, it goes away and the old scroll lines come back. And there's an escape sequence that controls the transition between the regular display and the full screen display. And what this does is adds one more mode where you can display any HTML. So you don't just display text, we can display any HTML here. And you see what it can do with that. And so the browser connects the GraphTerm server using WebSockets, and the host computers where the terminal session also connect to the same server. There's a diagram that'll explain this. This is not the way things happen usually with like SSH servers, so it's very different. I'll explain it more as we go along. And there are several programs that you can use when you're using GraphTerm. They're like LS and VI, but they have a G before them, and they do graphical things. So you can still use LS and VI, but if you want the graphical stuff, you add a G to some of the program names, and then you can use those. So this is the architecture, how it works. So there's a server program that's basically Tornado. It can run on any computer. It's pure Python, so in principle it could run on Windows as well. So it runs on the Mac and Linux, and actually I've been running it on a Raspberry Pi. So if you've heard about the Raspberry Pi, I actually have it in my bag. It's about the computer this big, costs about $35. But it runs even on that because that computer supports Python. So you can have a bunch of browsers connecting to the server, just like you connect to a web server. And this connection is done using WebSockets. But you can also have a bunch of terminals, basically bash shell, connecting to the server as well. So connection is initiated not by the server, but by the terminal program. So you run a program on any computer you want to connect to the server, and it connects to the server. And you open up a browser on any computer you want to use the terminal, and that connects to the server. Okay. So this part is normal, but this part is not. Like if you're using an SSH server, individual hosts would connect in this direction. So you connect from the terminal to the server. But here, this part is not a server, it's a client. which means you don't need any authentication to this part. You can just connect to the server. So this is the multiplexing part of the talk title, that you can have any number of browsers connecting to any number of hosts. And the server, all it does is it looks at where the input is coming from and which terminal it's headed to and just routes it, okay? Which means that if you have computers, my presentation is actually running on a graph term right now, okay? It's not running on PowerPoint or anything like that. It's at an URL, and if you type the URL in your computer, you'll see this, what I'm seeing now. And any number of people can actually do that at the same time. All the server does is it takes this and just duplicates it to all the people who are using the same URL, okay? And so you could, I'm going to teach Python from a programming class, and I can multiplex it, and all the students are here. And I can see any student's screen by just typing the student's URL. You'll see that in a moment. So the architecture is slightly different from the traditional server-to-server architecture for SSH. How do you install it? It's a standard Python program, so you do easy install graph terms, and then you need to do a setup because you need to set the executable permissions for the commands. That's the only reason you need to do the setup. And then you fire up the server. You say gterm server, and authentication code is none. I didn't make this the default because there are all kinds of security implications when you do this. So every time you type this, you know that you don't have an authentication code. So if you're doing anything public, you might want to set an authentication code. And so the way you access this is, by default, it fires up on the local host on the loopback server, so you can't access from outside. So it is safe that way. It runs on port 8900. All of this can be changed by options. So any terminal URL looks like this. You put the host name, the port, and the host. Sorry, this is the sort of IP host name. And then you have a host name for the terminal you're connecting to, and that's typically local for the local host. And then you put the name of the terminal. And you can have anything here. You'll just create terminals as you go along. The other nice thing is you can put asterisk in your URLs. Okay. So if I have like 10 hosts, and if I put an asterisk, it'll access all 10 hosts simultaneously on one screen. I'll try to show the demo. It's similar. I don't know if any of you used a program called CSSH, cluster SSH. You can actually have 10 computers, and if you type ls, it'll send ls to all 10 computers, and you can see the output of all of that. It's the same kind of thing, but so if you want to manage 10 computers from one window, you can just put an asterisk. You can put wildcards anywhere in this URL. So you can, same TDY on multiple hosts, or multiple terminals on the same host, whatever. It's just like a wildcard. And when you open up one of these sessions, the first user owns the session, and other users who use the same URL just watch it. And so that's where you can share it. And you can also connect additional hosts to the server. I left a few minutes for a live demo, so we'll see some of that as we go along. So it's backwards compatible. It's clickable. A lot of things become clickable. They'll be blue in the display. And it's basically Python and HTML, so it runs on all kinds of things. And you can also use it on the clouds. If you want to fire up, if you're teaching a class and you want to fire up 10 different instances on Amazon or something, you can do that as well. And all of them will be connected to the single server. Okay, now I'm going to, these are screenshots. I might skip this and do the live demo. This is a backup if the live demos fail. That's pretty common. So this is a backup. So let me go to the live demo, and then if it fails, we'll come back to this. Okay. So as I said, I'm running this on GraphTerm. And what you're seeing, I'm just running the browser in full screen mode. That's why you're seeing it like a presentation. And all it's doing is displaying a bunch of images, the slides from my PowerPoint slide, which I create, a presentation I created. So I'm going to, you can leave this in two ways. You can escape, or you can do Control C. So I'm going to do Control C now. So that's the nice thing, that you can get out of anything by pressing Control C. That's sort of the definition of the command line. So I just Control C out of my presentation, and you saw the controls. The way I was controlling the presentation was space to go forward, backspace or B to go back. You can Q to quit, or Control C to quit, or P to pause. So I was controlling it using the keyboard. The command I used to create the presentation was called gimage. And all it does is display a sequence of images, one after the other, depending on these commands. And F says it's full screen. And I'll show you what this does if I don't use the full screen option. So first I'm going to do this command called GLS, which is a graphical version of list. Okay, so this is GLS. It just lists all the files in this folder. So there's a bunch of slides which are created from a PowerPoint presentation. And what I can do is, by default, GraphTerm operates without icons. So it just looks just like an Xterm. So if you can see, it just looks like an Xterm. So what I'm going to do now is turn icons on. Sometimes you want it, sometimes you don't. So I turned icons on, and now you see it looks like a GUI right now. Okay. And these icons were always there. They were just hidden until I turned it on. You just didn't see them. So then I can do things like click on them. That's what you do on a Mac, for example. I clicked on slide 11. Let me try that again. I'm trying to get it up. Okay. There's still some minor glitches, but I had to put a -B option. I'll explain that later. But what you can do is, this is my slide that I showed you earlier, but you're seeing it inline in the terminal. This is my terminal. You can see the commands. So you can display any image inline. And so it's just like if you click on your Mac, on your GUI, it opens up the image. So you can do that for any image here. And sometimes it gets very cluttered. So what I can do is collapse the display. Let me do PWD and then collapse. It doesn't collapse the last one because I'm still looking at it. Okay. That cleans it up. So all this did was it took the standard output and standard error of every command and hid it from you. It's all there. These are all the commands I've typed since I started the terminal. And it's all hidden from you. And if I want to see the output, I just click on that and it goes back. Okay, so it's like the history command that you do in the shell, except that you can also look at the output by just clicking on this. Okay. So you can do listing files. The other thing is I do check the forecasts every day. I'm in the meteorology department. So you can do weather. It's a graphical forecasting, forecast display. So I want the weather forecast for College Station. Let's see if live demos work. Yep, it worked. And so this is, it queries the Yahoo Weather API, and so what you see is a graphical forecast. And so the textual forecast. So here actually the graphics is useful. I mean, looking at the clouds tells you something more quickly than reading the text. So you can mix graphics and text without losing anything. So I can run VI here, for example. And you can just go ahead and use whatever you want. VI just like you use a terminal. And then you can quit. So you don't lose any of the flexibility because it basically emulates Xterm, but it adds its extra features. And you can write programs that behave differently depending on whether there's graphics available or not. And the other thing you can do is to make your programs more user-friendly. And here's an example where I run the weather program, but I don't give it an input. I don't tell it where to get the forecast for. So when it sees that it has no command line arguments, it automatically opens up an HTML form. This is actually an HTML form. As I said, you can display any HTML. So it displays a form. And you can add helpful information for the user and so on. So let's say I want the weather forecast for Austin. Okay? And you just type it in and press enter. It's just like you don't actually have to go use the mouse. You just automatically shift focus to the form thing and press enter. Okay. The nice thing here is that the command option you typed in is saved as a command. So if I go back on the shell, it's there. Okay. So everything you do with the GUI is recorded as a command, and you can go back, edit it, redo it, whatever you like. And that's actually very useful because so if you're a new user, you don't know what the commands do. You go in and use the HTML form, but the next time you can see the command, you can just edit the command, put something else there. And if you're a system administrator, you want a record of what you did on the GUI. It's there as a bash script. And you can actually run the script. It's just a bash script. Okay? So it basically audits everything you do with the GUI that it supplies. And you can also do this on your iPad. This works on iPad too, because again, it's just WebSockets. And so it's actually very useful because whenever I try to use the terminal on the iPad, it's just impossible. The virtual keyboard and this. I mean, iPad, you don't really want to type. I don't know if Microsoft will succeed with Surface, but on a tablet, you want to avoid typing. I like the tablet. My kids like it even more, but you want to avoid typing. And I still like to use the command line, but actually you can do, I use this with the iPad, and I go around touching things, and the commands are created for me. And occasionally you have to type in things, but quite often you can just press the thing you want to press on. And whenever you really need to do something complex, you go in and use the virtual keyboard and put up with that. So that's a nice thing you can do here. So that's one of the demos. Let me look at some of the other demos.
You type the command just real quick. I want to see something about the environment. Can you echo out $term?
Yeah, you want to do N, ENV?
Yeah, echo $capitalized term.
Oh, okay. Actually, there are a lot of information there. Let me do the full ENV. You'll see a whole bunch of things. This is what you wanted, the term. It just says extern. It says extern. All your command line programs think they're running on an extern, okay? Because it's not a full extern. There are bugs in this, but it's supposed to be a full extern emulation. Most things work. The way extra things work is all these extra environment variables. The graph term, dir, that's where all the commands are stored. Graph term prompt, graph term URL, there's a whole bunch of these. Actually, one interesting, that's actually a very interesting security question here. There's an environment called graph term cookie. I can't see very well from here. Yeah, here it is. It's actually a number, it's a random number. So whenever you want to do any graphics in the terminal, you have to supply the cookie. The problem is, the reason you need the cookie is that it uses escape sequences to do the graphics. And someone could create a file that contains escape sequence, and you do cat on the file, and now they have control of the computer or something. So it's only interactive. A program has to grab the cookie from the environment, put it in the output before anything will happen. So this is a security measure. It's like if you do SSH with X Windows, similar things happen. You have these cookies. Because X Windows, you can do similar things. So command line programs don't know they're running on GraphTerm, but GraphTerm programs check for these environment variables. That's how they know. And the programs that are well written, weather will work in the command line. It'll check for this. It'll see there is no GraphTerm, and it'll just let me see if that works in the command line. Let me get out of this for a moment. Well, I'll just show the command line version of it. I don't want to quit this. But I say y weather minus t. I haven't fixed it yet, but it's showing the full text output. This is what, basically you can see the HTML that's being displayed. This is actually not a well-written program yet. But a well-written program would just display the text part of it because it's not running on the GraphTerm. Okay. Any other questions? I mean, as I said, anything else you want to see that you think it can do or not do?
Does it support syntax highlighting?
The only thing that's built in so far is bold. I mean, you can do bold and not bold. I haven't put on the color yet. Okay. Okay. But the only thing it knows about is bold and not bold. But at some point you stop using okay, that's a demo I need to do. Let me do that. Let me create a file. Let me create a file with VI. So I created a file with VI. It's called ABC. And actually, this is not running on my laptop. It's running on a. You can actually, if you have a computer, you type this URL, qrtx.graphterm.net. if you have a computer or iPad, you can do this right now. This is running on an Amazon cloud instance right now. I've been doing all this on the cloud instance. And you can actually, I'm not protected in any way, so you can go and mess up my presentation if you like. I'll kill this instance at the end of the day, so I don't care what you do there. But if you want to try it, just type pytx.graphterm.net and you'll see things there. You can do whatever you like. Just don't delete my presentation. But, so I created a test. Oh, someone had a question, right? Someone had a question?
Logging in.
You're logging in?
Does ask for using code.
It shouldn't. Does it? It will take a few seconds to disappear the user code. Does it? Just hold on. What browser are you using? It should work. Anyway, anybody else manage to log in? Got in? Yeah, you can do whatever you like there. If you click on new, it'll open up a window.
If I click steal session, will that work?
Don't do that. Steal session will take control. The reason steal session is there is if I'm working at work, and if I get to log out, I can go home and steal the session for myself. Or you can steal it from your friends, or if you're collaborating. But don't steal my session, please. Otherwise, I'll just go back to my laptop, and that'll be safe. But that's why I'm running it on the cloud instance. I'm not running. You don't want to run it on your laptop and put it on a public IP address. I mean, that's not what you want. Okay, I created a file. So you can use it, edit it using Emacs or VI, but there's a GVI. That's the GVI. Oh, didn't work? Oh, it did. Okay. So you don't need to use VI and Emacs anymore. You can use it. I tend to use it by habit. But what this does, it fires up one of the JavaScript editors. It's called ACE. There are a couple of editors. This runs on your browser. So it takes a copy of the whole file, sends it to your browser. So you're editing it locally on the browser, so it's more responsive. Okay. And so I got a line to it. Added a line. So this is not happening on your computer. It's happening on your browser. So the feedback is much more, much more responsive. Then I can save it. Now I do cat ABC. That's been edited. So at some point, you tend to use VI less and you start using these JavaScript editors more because they have much better syntax highlighting and so on. Again, you don't have to leave the command line to do that. It's integrated into the command line. So that's something that's really useful. Anything else you'd like to see done with the that you think you can do with the command line and the GUI together?
What's the regular expression support like in the GVI?
GVI is, I'll show you the script. That's a good way to look at it. Let me look at, let's see, which GVI. It's not a very big script. So one thing that's still a little tricky is copy and paste. You have to do a little extra stuff to do copy and paste. Because this is just a web page, and since it's a regular web page, there's some security things. The computer won't let you access the clipboard because security. So I'm going to look at this using GVI. So all I did was I copied I found out where the GVI was in the path, basically supplied with that, and I'm going to look at it with GVI. Okay? So so it's just a regular script, and you can see it's actually a bash script, not Python. You don't need to use Python because it's all done using escape sequences. And it just does, it goes to the argument. It's very dumb. It looks slow, I think. And so the regular expression supported right here, just all the stuff. So it's just standard bash script. Okay. Does that answer your question? Yeah. So it's a bash script, so whatever you do with the bash script is what you do here. And let me give some more examples. So the one thing I'm going to do in the spring is to create a bunch of cloud instances for people to log into. And you can do that using the Amazon Web Service. There's a command called EC2 launch. So it takes a whole bunch of options, and you can see that if I put the -H. Oh, it won't work here. I might switch back to my laptop because it needs the access control. Let me see if I have any more demos in my I'm just going to start up my presentation again and skip to see if any slides I haven't shown. Yeah, okay. So these, I'll quickly go through the screenshots. So this is the LS versus GLS. This is the weather forecast. And this is a collapse mode where you can really collapse the output and see just the commands. And you can click on them to see what. Oh, this is the mode. I need to show you this. I forgot about this. This is Star Wars mode. Let me go into that. That's sort of the highlight of the presentation. So you can do, let's say I do, let me do the GVI command, but using VI. Okay. I'm going to repeat the GVI command. I'm going to use VI because it only works properly in VI. So that's your, it's not a very functional mode, but if people ask you why you're still using the command line, it's a theme, basically. It's CSS which adds perspective to your thing. It's not the one you'd use if you're doing a lot of work, but if you want to show off, this is exactly the thing you'd use. So you can actually, you can scroll down and scroll up. Okay. And as I said, this is just a theme. The actual text you're looking at, if I turn off the theme, this is what you're looking at. It just made it look nicer. There's no difference. In terms of content, this is exactly what you're looking at. Just added some colors and perspective and a background to it. So you can show off to people who are not using the command line that this is a lot cooler than what they have right now. Let me go back to slides. So that was the 3D perspective mode. And that only works on Chrome and Safari. Firefox doesn't support 3D perspectives. This is GVI. Split screen scrolling, I'm not going to demo that, but what it does, suppose you're creating a command line. You want stuff from up in the scroll buffer. It'll automatically split the screen, so you can scroll this part, but this part won't scroll. So you can actually cut and paste stuff. I mean, you don't have to cut and paste. You just click on it, that stuff will get pasted on the command line. It'll automatically happen when you need it. This is showing that you can run Emacs or VI in the browser. Some of the coloring and highlighting may not work as well. Here, you do have this does highlight bold, so that part's working. But that part is a little spotty, the highlighting part. Some of the applications, it's a sort of a more fun and perhaps more useful replacement for the terminal. The thing is, you can actually replace the screen and tmux because it's completely detachable. It's just a URL. And I won't try to demo the wildcard thing, but take some setup time. But what you can do is you can send output to multiple terminals at the same time. And there's an interesting issue, how to display the output, because output from different terminals may be the same or it may be different. So if it's the same, it actually won't repeat it, but if it's different, it'll output it. And you can also do things like you have a history of all commands. You can debug programs. That's for the next talk, but I'll talk more about it at 11. And you can do screen sharing. So if you're teaching a course and you want to see the student's terminal, you just type the student's terminal URL, and you can see that. can create a virtual computer lab. And there's another thing which you can do. I didn't demo that, but there's an option where you can get feedback from the users directly. So there's a feedback button that appears on the presentation. They click on it, they get a little text area window. You type something, and the instructor sees what the user is typing, real time. All it does is it sends the message back via WebSockets, and it appears on your terminal. So if I want to discuss things with the students, and this can work remotely as well, since it's just all web-based, so they don't have to be physically present in the class. Oh, this is some old stuff. So that's my presentation. I'll take any questions or anything you want to see demonstrated. Anybody else got it to work? Did you manage to log in? Oh. No. Yeah, I'm sorry, the GVI application, right? Any application, any fragment of HTML can be sent to any application. It can be in any language. It doesn't have to be Python. You just have a special escape sequence with a cookie before to say that this is HTML, not text. And what the server will do, actually the browser will do is it will basically create a div for the HTML and display it in the command line. So it can be any HTML to some. There's some issues because this HTML is inserted in the page, so the JavaScript namespace thing, it can be a big mess, but in principle it can do anything.
Yeah, if you connect, look at hello.sh.
Mm-hmm.
I just had it follow.
Okay, this is going to disappear at the end of the day, but
Yeah,
it's on throughout the day, so you feel free to do anything. Don't go around hacking military installations, but I'll kill it at the end of the day. But you can actually set up your own cloud instance. That's the reason this supports cloud instances directly, because you don't want, quite often if it's public, you don't want it on your computer. You want it, and so the easy to launch will do that for you. If you have, it's very easy to use. If it's easy to launch, as I said, this doesn't require security credentials, so I'll go back to my local computer. So I'm running. So I'm switched now from the public one to the local one. Okay, so when I run EC to launch, you have the security credentials entered. It'll ask you for the type of instance you want to create, the key name, all this is filled in. It'll automatically load GraphTerm and everything for you. Oh, the one more demo is PyLab. I didn't do the PyLab demo. Let me do that quickly. I don't see the other speaker yet, so. Let me go. Let me do the PyLab. Do any of you use Matplotlib for visualization? Well, it's basically a plotting program like Maple or Mathematica. So if you're doing plotting, if you're doing a scientific computation, you want the output display. You can even animate, but what it does is, again, use the escape sequence. You can display the plot inline into opening up X Windows graphical display inline. And it's very useful because X Windows is slowly failing on the Mac. I get my students to use X Windows Tunnel. Mac doesn't support it very well, and slowly. So you can use basically inline images instead of relying upon X Windows and opening up a separate window. All it does is display, you got to create a PNG file.